This is Checkpoint Quiz 11.10, problem number 2. Graph the parametric equations. X is equal 3 cosine of t, comma y is equal to negative 3 sine of t over the region from pi halves less than or equal to t is less than or equal to 3 pi halves. Parametric equations that involve sine and cosine might have a structure that you can identify prior to making a table of values and plotting points. For example, if we remember that x squared plus y squared equal r squared is a circle centered about the origin with radius r. And if we check, x squared would equal 9 cosine squared t, and y squared is 9 sine squared t. Let's see what happens when we add them together. X squared plus y squared is 9 cosine squared t plus 9 sine squared t, and we can factor out a 9. X squared plus y squared is 9 times parentheses cosine squared t plus sine squared t in parentheses. And if we remember the Pythagorean identity, cosine squared t plus sine squared t is equal to 1. That tells us x squared plus y squared is equal to 9. This is a circle with radius 3 and centered about the origin 0, 0. Hence, we would expect the parametric equations to lie on a circle of radius 3 centered about the origin. The question is, do these equations form the entire circle or just a portion of it? To answer that question, we need to look at what values the parameter t takes on. T is going from pi halves to 3 pi halves. Look at the x component first. X is 3 cosine of t at t equal pi halves. The cosine of pi halves is 0. That means that the x component will start when x is equal to 0. Now, at 3 pi halves, the cosine of 3 pi halves is also 0. Therefore, at both the starting point and the ending point of t, we have x equals 0. Now let's take a look at trying to figure out a maximum value for the x component. At t equal pi, the cosine of pi is negative 1. We would expect a half circle from the region of pi halves to 3 pi halves for that parameter t. Let's check to see what happens in the y direction. For y equal negative 3 sine of t, at t equal pi halves, the sine of pi halves is equal to 1. And then at t equal 3 pi halves, the sine of 3 pi halves is equal to negative 1. And at t equal pi, the sine of pi is 0. So we see the y direction has maximums at pi halves and 3 pi halves, and then it reaches 0 at pi. Putting that together, we would expect the parametric equations to lie on a half circle on the left-hand plane. And we can verify this by looking at our points. At t equal pi halves, x was 0, and y is negative 3 times 1, which is negative 3. It looks like the starting point is at t equal pi halves. We have a point of 0, negative 3. Now, as we increase t to pi, x is 3 times the cosine of pi, that is 3 times negative 1, gives us x equal negative 3. And y value at pi is 0. This point is at t equal pi. We have a point of negative 3, 0. And then at t equal 3 pi halves, x is 0. The sine of 3 pi halves is negative 1, and negative 1 times negative 3 is 3. We get y equal 3. On the axis between the first and second quadrants is 0, 3, and that occurs at t equal 3 pi halves. The direction the curve is tracing out, it's tracing out a clockwise orientation